going to begin with a method called between ratios. And this is what this looks like. This is a lot like finding equivalent ratios. So take a look at this proportion that I'm showing up here and see if you can find a relationship where there's a certain multiple somewhere. Take a moment. Well, I hope you saw that there's a connection between the 7 and the 28. So we have a relationship between this ratio and this ratio. And the relationship works like this. If we multiply 7 by 4, we get 28. So to solve the proportion, we can do the same thing with the 3. We multiply by 4 to get 12, which is our final solution to the value of x. So this proportion means 3 to 7 is the same as 12 to 28. And we benefited from looking at the relationship between the 7 and the 28. Take a look at this one. In this case, see if you can identify a relationship between the two ratios. If you saw that from 5 to 15, we multiply by 3, you are right. Take a look here. That is the relationship between the ratios. That means that for us to find the value of x, we would need to multiply the 12 by 3, which gives us 36. That is the solution to our proportion. Very nice. One more example. Identify any relationship between the ratios. I hope you saw that 21 and 7 are connected in this way. If we take 7 multiplied by 3, we arrive at 21. Or we can think 21 divided by 3 is 7. And we benefit from these by then multiplying the 9 by 3 to solve our proportion. And the final answer is 27. So this proportion would be 21 to 27 is equal or is the same as 7 to 9. One last example of the solution between ratios. See if you can identify the connection between the two ratios here. You probably already did, and you realize that 36 is a multiple of 6 because 36 divided by 6 gives us 6, or conversely, 6 times 36, 6 times 6, is 36. So in this case, it's a bit different because we realize needing to find the x, we need to go in this direction, and in this case, we were dividing, which is perfectly fine. Sometimes we find multiple uh, ratios by multiplying, sometimes by dividing. So in this case, we divided by 6, so we would do the same thing with the 42, meaning we divide 42 by 6, and then we arrive at 7, which is the solution to our proportion. So this is the method of between ratios, when we can connect one ratio to the other, and it is a lot like finding equivalent ratios that we've been doing before. The second method we're going to learn is something we call within ratios. Take a look at this proportion that I'm going to show you now. And in this case, the multiples are within the fraction. Take a look at it. We can see very quickly that really there is no easy connection that we can ascertain between this ratio and the second ratio. However, if we look carefully, we notice that there's a connection between the 3 and the 12 because 12 is a multiple of 3. So we can take advantage of this connection within the ratio of 3 to 12 because 3 times 4 is 12, and that will allow us to solve the proportion by doing the same thing to the 7, meaning multiplying by 4. Therefore, the solution to our proportion is 7 times 4 equals 28. Same thing here. We can see that there is no real quick relationship between this ratio and this because 10 and 8 are not exact multiples of each other. However, we can notice there's a relationship between the 8 and the 4 in the 8 to 4 ratio. And we can see easily that if we were to divide 8 by 2, we arrive at 4. And we take advantage of this to do the same to the 10. Therefore, we divide 10 by 2 to arrive at 5, and 5 is the solution to our proportion. One more example here. See if you can determine what is the relationship within one of the ratios. I hope you saw it, that we have this relationship. 5 multiplied by 3 is 15. And if we apply the same logic to the 11 and multiply by 3, we arrive at 11 times 3, 33, which is the solution to our proportion. Take a look at the last one and see if you can determine the relationship within. Remember that every time we're looking at proportions, we are looking at either multiplication or division. So in this case, we can see that if we were to multiply the 7 times 7, we arrive at 49, and therefore we can apply the same logic to the 20 to find the x. In other words, 20 times 7 equals 147. So this method we use when we don't see a relationship between the ratios, but we see the relationship within the ratios.